All right, thank you very much for coming. My name is Barry Dorrans. I'm the .NET Security PM, which means I deal with everything when it goes wrong and try and make people do things right in the first place, which is a much harder job than you would expect. So this talk is about the things that went wrong. The things that cause Patch Tuesday issues, which is an absolute joy. And to be honest, none of these things are really .NET specific. They happen in a lot of languages, and they happen not just in things we would do in the framework, but also things that you might do in your own code, which is why I like giving this talk. Also, it's fun, and I get to swear a bunch. So I'm going to go through 9 MSRC cases, hopefully, in 40 minutes, and 1 advisory. The full version of this talk then also has things that we've caught before they've become Patch Tuesday issues, but in 40 minutes I don't have time to do that. If you go to my website, it has non-abridged versions of slides and recordings of all of this, and it talks about things like zip bombs and billion laughs in XML and how you're completely screwed if you're going to accept any type of file upload to your website. So I would advise doing that. The way the Microsoft Bulletin process works, in theory, when it goes well, is someone will send us vulnerability details to secure@microsoft.com, and someone reads those and decides which product it gets allocated to. The product group security group gets emailed, so that's generally me for .NET. And then I sit down and I try and reproduce the vulnerability from sometimes the absolutely wonderful details that people give us, including like, here's the line of source where things are wrong, and other times it's like, well, here's a video of something going wrong because my English isn't very good and I can't explain it, so you have to work it out from the video, which can take a while. If the reproduction works on my machine, then it gets tested against every single supported OS and software configuration. There are a lot of supported operating systems in Microsoft. I don't just mean we're supporting like, Windows 2012, Windows 2008, all the way back to XP if you have a really expensive extended support agreement. But it's every language that these things are in, and there's an awful lot of languages. Some languages are harder to test than others. Trying to test a UI in German where the words are like that big, when in English or in Swedish they're that big, can be fun. So reproduction can take a bit of time. So that's sort of the left-hand side. It's probably a week and a half. Then we move on to, well, here's where the error is. Someone go and fix it. That usually takes about a day. Then testing the fix will take about 3 weeks. And we do test fixes. I know a lot of people won't believe that, considering the screw-ups that Patch Tuesday has been. But things do generally get tested. Then I write the security bulletin or the CVE or the issue for GitHub, and then the fix gets pushed internally to see if it breaks anything, and that probably takes 2 or 3 weeks for it to filter through all our own desktops and a bunch of telemetry taken. And then finally, on Patch Tuesday at 10 a.m. Redmond time, although we've all been in since about 6, the bulletin and the fix is released. And then everyone ignores it and doesn't patch because that's what you all do. And then when something goes wrong, someone will go, why didn't you fix this? And I can go, I did 3 months ago. It's your own fault. So I'm going to go through a bunch of security bulletins with a little bit of demos. And we'll basically just see how this goes. So we're going to start off with a hash denial of service. I'm sure a bunch of you have been asked to implement hash tables in job interviews from scratch because that's what interviewers like to do to make themselves feel clever, which seems to be a constant in technical interviews. So this was caused by the fact that the hash algorithm we use in dictionaries in .NET was predictable. So the hash value for Reggie, my little pet dinosaur, would be the same from run to run. So what you could do is you could pre-calculate all of these things and then cause a collision. I know better than to ask Swedish audiences, do you know what a collision is? Because audience interaction is not your thing. So I'm going to assume there are people out there that don't, and I'm not going to ask you to admit to it because that just will not work. So I'm going to explain it anyway. So imagine you have, you run a boarding house for cats, and people drop their cats off when they go away on holiday. And you have to put the cats in places where you can retrieve them back again. So the way you've done it is you have a simple hashing algorithm. You have 26 rooms, and you take the first letter of the cat's name, and you put the cat in the corresponding room. So the A room, the B room, the O with the slash through it room, whatever. So an evil attacker comes along to your cat boarding house and says, I have 1 million cats, and every single cat is named Alan. And you're like, oh. So you take the first letter of Alan, and you have the letter A, and you take cat number 1, and you put it in the A room, and that's easy. Cat number 2 in the A room. And 500 cats later, the cats are really, really unhappy because there's not a lot of space in A, and it's getting harder and harder to shove the cats into the room. And that's your denial of service, because with every single insertion, it's going to take more time. And it is a collision because someone has pre-computed your hashing algorithm and found vulnerable values. So things are the same or close enough that it will take more CPU time to put things into your room. So we fix this by either saying, yeah, I'm only taking 50 cats total every day, so we can limit the size of the dictionary, or we switch our hash functions to ones that are unpredictable. So we put a random value into the hash function at process start. So I can look at here. This is the non-cat explanation for each of these. There are notes in the slide deck that will go to the papers that people have presented at conferences. This was originally against PHP and Java and Python and JavaScript, and then some smart ass thought that it would be funny to move this across to .NET. So that didn't make for a fun September. So here I have a C# demo of it. And what I have is I'm going to put a few cats into a dictionary, 1 million cats into a dictionary, and then I'm going to put dumb cats into a dictionary. And the way I'm going to emulate this is I'm overwriting get hashcode and just returning the same value regardless. Now, I'm sure some of you have overridden get hashcode in your classes, and you're going to be very nervous right now, and so you should be. So we'll run this with my wonderful UI skills. So putting 1 million cats into a normal dictionary using a normal hashcode takes 875 milliseconds because my machine is quite slow. The bad hashcode won't be done by the time I am done talking. So I'm just going to kill this. So for those of you that have implemented get hashcode, you should now be very worried. Haha. So the way you fix this is you don't use user input as keys. So there's no way for an attacker to do the pre-computation and affect your dictionaries. Or you put a random value, a session key, which is what we did to fix it properly in .NET. And it gets mixed with get hashcode in a cryptographically secure way. So from one process start to the next process start, it will be different. You have to opt into this second behavior in .NET Framework because backwards compatibility is a suicide pact, and we can't turn these things on because even though we said in the documentation from version 1 that get hashcode would not remain the same from run to run, none of you read the documentation. And apparently backwards compatibility is an important thing, which is one reason my job is so difficult. So, HashDOS. Next one is a padding oracle, nothing to do with the database. These are cryptographic attacks, and oracle is something that gives away information in an obscure way. If you've been playing Assassin's Creed Odyssey, you will know this. So an oracle gives things away in some sort of strange way, but you can interpret it to do things that you want. So we had an endpoint, web.resource.axd, that was supposed to serve up JavaScript files that were embedded in DLLs as resources. And the way that you would address this is you would give it an encrypted value of the resource that you wanted to pull out, and it would serve it up. It was a bit dumb in its initial implementation. And so we took the encrypted value and we tried to decrypt it. And the way that padding encryption works is it splits your data up into little blocks, and it takes the result of the encryption of the first block and feeds that as a seed into the second block, feeds it into seed in the third block, and so on and so forth. But the blocks all have to be the same size. So if they're not the same size, you add known padding onto the end to pad it out to the same size. And one of the first things that encryption does is it checks whether the padding is correct. So it checks whether the final block is of the right length. And that's a very, very fast operation, as opposed to like decrypting a block. So if you get the padding wrong, you can detect this. It's, you know, the variance in this is maybe a millisecond, maybe slightly more if you're doing it across the internet, but it's detectable enough. So what an attacker does is he tweaks the first bit in the last byte in the last block, and then looks at the timing, and then tweaks the second bit and the third bit and waits for the timing. And so by observing the timing and how long it takes to return an error, you can start guessing and getting valid values out of it. So you can work out what the encrypted value for something that you want is without having to know any of the keys, which is nice. Which means that I can forge a request for scriptresource.axd and said, hey, you know that you were limited to just serving up JavaScript? And it goes, yeah. Well, what if I ask you to serve up web.config? He goes, yeah, I don't mind, because it wasn't limited correctly. So the padding oracle for this could basically send a bunch of requests out, work out what the encrypted string on your machine would be for web.config, then ask web.config to be served, and lo and behold, all your connection strings with their usernames and passwords in them are now on the attacker screen. Worse, if you had used web.config to set a static machine key, well, they've got the encryption key for what we were using for webresource.axd, what we were using to protect your membership cookies with, so they could now forge a membership cookie and log in as admin, and so on and so forth. Kind of a problem. So the way we fix this is we fix scriptresource.axd to do what it was supposed to do in the first place and only serve up JavaScript. But when you encrypt data, encryption is not enough. You really need a way to detect if the data has changed before you perform the decryption step. So you have encrypted data and then you have a signature afterwards. And the signature needs to also be a cryptographic signature, an HMAC. Because an HMAC also has a key that is hopefully secret to you, so an attacker can't recreate it. So we're not talking SHA-1 here, we're talking HMAC SHA-1. So we also added a signature onto scriptresource.axd and didn't allow you to turn it off. So we would check the signature first, and if the signature failed, we knew that the payload was being tampered with, and we didn't even bother to decrypt it. So when you are encrypting, you also always need to have a signature, so you can detect if the encrypted payload has been tampered with, and then just go, nope, not touching this. So this was originally attack on SSL and IPsec, and then Ty and Giuliano moved it to ASP.NET because they thought it would be a giggle. So you fix it by not exposing padding oracles. You don't return detailed errors, because the more error detail you have, the longer it takes to return, and even that's detectable. And you just go 1 or 0 to indicate statuses and things. SharePoint and remote code execution. SharePoint is the bane of my life. They are the most problematic .NET user ever for me, closely followed by Exchange. So those of you that have used web forms will remember that there is a hidden form field called viewState. And viewState is used to serialize an object graph between requests. And there are things in the .NET framework that should never have been serializable. And when you serialize those things and you blindly deserialize them, they can have unintended side effects. Now, in this case, ASP.NET was secure by default because we had an authenticated signature at the end of viewState, so we could detect tampering. However, in order to get that to work across multiple machines, you have to set a static machine key in web.config, and SharePoint thought that this was a little bit too hard. So they disabled the security of having a view state MAC, which means you could put the payload that you wanted in view state, and SharePoint would happily deserialize it, and lo, you have remote code execution. So this was originally based on a remoting exploit discovered by my friend James Forshaw, who works for Google, and then it was expanded out and presented at Area 41. It was nicely presented, so we knew about it beforehand. We had a patch. The patch had gone out, and then he just demonstrates it against an unpatched version. So that's the sort of vulnerability reporting that makes me happy. So in this case, he used temp file collection. Temp file collection is serializable, and serializable classes can be shoved into view state. Now, temp file collection is meant for you to ask it, give me a random temporary file name, a unique one. And then when the temp file collection is disposed, it cleans up after itself. It deletes all these temporary files. But you can add your own file names to the temp file collection, which is fun. So if I switch across to this, where are we? Regular expressions, view state, here we go. Set a startup project. So this will create a remote code execution payload. I am not going to run SharePoint on my machine because I don't hate myself that much. But what the demo will do, and we'll watch it in Explorer, is I'm going to create a web.config file. And then I'm going to create my temp file collection. And I'm going to put web.config in my temp file collection. I'm going to serialize it, clear everything out so there's no cheating, there's nothing up my sleeves. And then I'm going to deserialize it again via binary formatter. Because binary formatter is the worst serializer for these sorts of things. And what it will do is it will delete web.config when the garbage collector comes along and collects temp file collection. And I'm going to force GC so we don't have to sit here and wait. So here is, there is no web.config. We can sort of see this. And so I'm going to run it. And there will be a web.config. There's my web.config. We can see it at the bottom. And I deserialize stuff. I'm going to force garbage collection. And when I go back, web.config is gone. And if you remember your classic style ASP.NET, when web.config is gone, your website goes down, which in the case of SharePoint is probably a blessing. Okay, there we go. And then Exchange, my second favorite target, decided to take this one a bit further. This is this year. This is why every time I give this, I can add new slides onto this because there's bound to be something. Exchange also used binary formatter. If you are using binary formatter as a serialization class in your code, I strongly advise you to go back and reconsider your life choices, because binary formatter is remote code execution waiting to happen. There are probably better ways for you to format things. Don't use binary formatter. So Exchange had an authenticated endpoint in Exchange Web Services, so it wasn't so bad. Someone had to have an account. And it had this endpoint that accepted voicemail for transcription. So, you know, you leave a voicemail in the Microsoft voicemail system, and then you get this transcripted version emailed to you that makes no sense whatsoever and doesn't match what the voicemail actually said, because that's how transcription works. And the voicemail was binary data formatted with binary formatter. And I'll show you how bad this can get in a minute. Docker, it's not just us. Docker also had the same thing. Docker was using binary formatter. You see the common thing here. Don't use binary formatter. It allowed commands to be sent to the Docker controller over named pipes and windows. They hadn't ACLed the named pipes, so anyone could shove things into them. And the Docker server runs a system. So you, as a lowly normal user, could now start sending commands that would run a system on your Windows machine. Great. So if I switch back to this, where did you go, Visual Studio? My mouse battery's run out, so I'm having to use the touchpad, and I'm never very good with touchpads. Come on. So the way I demonstrate this is I'm going to demonstrate remote code execution that will end up showing the most horrific thing possible for the conference or for the country that I am presenting in. So this has been customized just for you folks. Actually, the most horrific thing would have been someone with their hand up asking questions, but I'm not that cruel. So what I'm going to do is I have payload that's hidden away, and no, you don't get the source code for this one, because this one's just horrible and dangerous, and not everyone is patched. And I'm just going to have binary formatter. I'm going to read in a stream, like you would do, and then I'm going to call deserializer on it. Seriously, if you're using binary formatter, you need to go examine your code. So if I hit start. Oh, I'm still in view state. Thank you. Painful lessons all around. So, oh, where did there's no PowerShell in the code. It's going to do something. It's doing something really, really bad, and the most horrific thing possible is your bloody herring, that rotted herring that you have to open underwater. So, not something you want to see. Okay, it's funny popping up a picture, but having PowerShell running on a server when you didn't start running it, downloading executables off the internet, is a little bit more serious. Although that is friggin' disgusting. In Australia, what I do in Australia is I have a picture pop up of England winning the Ashes, and last time I did this, I heard boos in the audience. I was so pleased. So, when you are round tripping any sort of thing to user state, or to into user controlled space, or accepting something from user controlled space, that is serialized data. Add a signature, and add a cryptographically secure signature, so you can tell it has come from you. It hasn't come from an attacker. It hasn't been changed. And you don't publish your signing key, so you don't check in your signing key on GitHub like so many people do, because we've seen that a bunch. And you don't allow any serialization formatter that allows an attacker to specify the object type to be serialized. So binary formatter is very easy, because in the binary formatter format, you can say, okay, this object is type X, and here's all its properties. This object is type Y, and here's all its properties, and you don't have to think. You can do an entire object state. And what the attacker will do was change the object type to something that will introduce remote code execution. So in Black Hat, last year, there were a bunch of things that were, aside from binary formatter, called out. So if you're using any of these, anything that doesn't have a type resolver, you are screwed right now. You need to go carefully look all of your serialization code and look for things that don't allow type resolvers. You don't look at things that you can't, that don't have the ability to say, oh, and by the way, I'm only expecting this type of object. And again, this just isn't a .NET problem. All those Spring exploits you've been seeing over the last year and a half, it's this. It is using binary formatted data where you don't have a way of constraining the type that it's going to be deserialized into. If you take one thing away from, well, two things away from this, sign everything with an HMAC, and re-examine how you're saving your data through serialization. If you have to use binary formatter, We believe this will help. It won't help entirely because it's quite possible to denial of service attack this and give it into a tailspin, and so you run out of memory. But frankly, running out of memory in your application is better than allowing someone to execute code on your server. So the slides will be published at my website at idunno.org, idunno.org, and this sort of serialization binder will help. And why can't we fix this in binary formatter? Because you all love backwards compatibility too much. We would break things. This one I will ask for audience participation. How many of you use regular expressions to validate data? Okay. In .NET, I think it was 4.52, we decided we would add some more input validators. And we took the input validators from jQuery because taking things that are fine on the client and putting them on the server was a really good idea. And with regular expressions, you have the concept of backtracking regular expressions. So it moves like 2 steps forward, encounters something, moves 1 step back, and reevaluates. And so you can get yourself into a tailspin and an exponentially growing parsing. So you fix this quite easily, actually. When you're doing regular expressions in .NET, there is an optional parameter of a timeout value, which none of you will have used. You need to start using that. So we'll demo this. This one was great because it was reported to us by one of the European spooky agencies, which was quite embarrassing. So here we have a regular expression. Now, some of you, I would imagine, are using regular expressions to validate that an email address is in the correct format. Would anyone like to stick their hand up and admit to that one? Or do you realize what was coming? Oh, yeah, you're going to love this. So here is the regular expression for checking an email format right here, okay? Would someone like to try and describe this? I have a Raspberry Pi for someone who could work out what this is. Why are you using regular expressions for this? If it contains a dot and it contains an at, it's probably an email. The right way to validate an email is send an email to it. So we have the regular expression. It's going to test it against the good value and then test it against the bad value. And because of this backtracking regular expression that comes from jQuery, it's going to sit there for a very, very long time. It's exponentially growing against, and honestly, a quite simple, weird-ass input, which was t at t.t.t. blah, 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 blah. And that with the space in it. It's the space in the end that's the key here. Why hasn't jQuery updated this? Because who cares if you DOS yourself? You're just killing your own browser. No one cares. So the way to fix this, aside from timeouts, is find a better way to validate something other than regular expressions. That was not maintainable. I know regular expressions make it easy for you to keep your job because you're the only person that can understand what you've written, but you're a bad person. Okay? You need to set timeouts in all your regular expressions. If you are on full framework and you don't want to review all of your regular expressions because you're a bad person and you've used them everywhere, you can set a global timeout for your entire application for every regular expression. And set that so you have a reasonable timeout. You're going to need to tweak it for individual ones. But this is a quick and dirty fix while you go and reevaluate your regular expressions and your life choices. And then we have cross-site scripting. Cross-site scripting is interesting. We put a lot of effort into MVC to make sure that we encoded everything by default. That's what the @ sign does. But there is a way to tell it not to, which is by using html.raw. And I had written, and this is one reason why I don't write a lot of code anymore, I had written a bunch of, I had written the templates for a bunch of features that we added to .NET Core. It was around the two-factor auth bits and pieces. And they weren't idiomatically correct in an MVC way. They worked, but they weren't correct. So I handed them over to someone else to make them more MVC-like. And in doing so, they ruined all of my assumptions. So when we generate the two-factor auth key, I was taking the key from the server every single time and sticking it into a variable in the class. And someone decided it would be much better if it was stored in a view and it would be posted back. But these things were output as html.raw because otherwise we ended up with double encoding for some strange reason, which eventually we fixed. And so they didn't also limit binding in the view, and so you could set it in the query string, and lo and behold, all the hard work that we did was ruined. So look through all your code for calls to html.raw. Every single one of those should be closely examined to make sure that it is a valid use of html.raw. There are very few valid uses of html.raw. For things that come from user input, in your view models, apply by never. If it's not supposed to come from user input, and if something is generated server-side, always generate it server-side. Stop doing what the person that corrected my code did, which was put it in a hidden field to transport it between requests. It didn't matter. It didn't change. And then we have CSRF, cross-site request forgery. Again, we have automatic tokens for this in HTML form. So cross-site request forgery is when badsite.com, when you visit it, can issue a command to goodsite.com. And because you're authenticated, it works. Because the way it works is, well, badsite.com won't see your cookies. When it sends a post or a get to goodsite.com, the browser goes, oh, this is going to goodsite.com, so my authentication cookies are coming with it. And we put tokens in all of our forms to prevent this. So a value is generated on a per user basis, and it's embedded in the form. So if an attacker looks at the form, they get a different value to you. So if they construct a form and post it, they're going to send it with the wrong value, and then you get a CSRF token validation failure, which was great. And again, when I did the initial versions of those templates, this was right, because I am invincible. Look at me channeling Bond. So someone decided that they would change the two-factor auth recovery codes to not be a form anymore. It would be a GET request. And so all the automatic stuff that we had in there to prevent CSRF goes away, because GET requests don't need it. Because as we all know, GET requests shouldn't change state. Guess what ours did? So we fix it by making sure that GET requests shouldn't change state. When you change state, use a post. And don't allow people who optimize code for ASP.NET Core to fuck with your templates, because it just generally makes you unhappy. Okay. WSDL. How many of you remember SOAP and WSDL? I am so sorry. Are you being punished for something? Did you strangle kittens in a former life? This doesn't encourage audience interaction, does it? So, I don't need to explain what WSDL is then, apart from horrible. This was part of a nation-state attack. These are the things that I really enjoy, when we get someone that is trying to protect a government email us going, hey, we've seen something really weird. Would you like to explain it? So WSDL is metadata for SOAP endpoints. It's used to generate proxy objects. Did you know that .NET Framework had a WSDL parser built into it? I didn't until I got this email, because I thought all the WSDL parsers and the proxy objects generations were just part of service util. They were external tools. But no, someone thought it would be a great idea to stick into the framework. And we're about to see how bad an idea this was. So inside the framework, the IsValidUrl call had a wonderful bug. This enabled an unnamed nation state, which was targeting Russian speakers in an Eastern European country. Yeah, it was Russia fucking with the Ukraine. It was pretty obvious at this point. To compile code on their machine, because they had put comments in a WSDL document that mixed up the parser. The parser didn't strip the comments out correctly. And then when it's generating the proxy object, the comments mess around with it, and you can put a code payload inside the proxy object. And so that was fine. That would have been okay if it wasn't for the fact that Word decided it would be a really good idea if you could embed WSDL documents and SOAP calls inside a Word document and call them and parse them with no prompting whatsoever and use this code that's built into .NET. So the Russians constructed a Word document that had this WSDL parser bug, that was using this WSDL parser bug to generate code. And so what Word did was, hey, there's a WSDL document over here. I need to compile it so I can call the SOAP service on the other end. And so it compiles it, it then loads it into Word and runs it. And lo and behold, we have remote code execution. Thank you, Russia. So you fix this by not annoying Russia, frankly. I mean, let's be honest, that's getting easier these days. It's far easier to annoy the US, given their current leadership. And you don't write code that generates code from user input, compiles it, runs it, loads it into your user space, and executes it silently. That's just incredibly silly. This was an interesting one for .NET, or for .NET Core. When we started .NET Core, we rewrote a web server, which gave me incredible headaches because no one wants to write a web server from scratch. And we told you, please don't expose this directly to the internet. Stick it behind a proxy. And then in version 2, we were like, okay, it's not been too bad. Maybe we can remove the proxy out of the way. And then we discovered how bad it could be. So URL helper in all your MVC views has methods for generating URLs, and it includes, unfortunately, absolute URLs with hosts in them. There's nothing in MVC that says, oh, and by the way, this is my URL. The way it takes the host is it comes from the host header. And the host header can be controlled by the browser. And that's normally fine because web servers will be sensibly configured to use the host header to route things by request. But Kestrel is designed to ignore the host header by default. It will, not anymore, it's getting fixed. It will go, I'm going to listen for any host header on this IP address. And you're thinking, that's okay. So I spoofed the host header. It doesn't matter because you're going to get fully qualified URLs back in a response, and the only person that gets that response is you. Except password reset emails have absolute URLs in them because someone needs to click through to get the password email. So what this cleverly did was it would send an invalid request with an invalid host header. It would trigger the password reset email. It would go to the user. It would look legitimate because it's coming from your website, but the links in the password reset email would go to the attacker's controlled web server. It's not entirely what we want. There was a bonus bug. Kestrel didn't validate host headers because we weren't using them anywhere, so we didn't care. So you could shove HTML in the host header, and certain email clients would actually, certain bad online email clients would render this. So the whole clicking of the link would be done just by you opening and previewing the email. This was not Outlook. This was not Office 365. I will not say who it was because at least one person employed by that company is in the room. So you fix this by, look, I know it's incredibly easy to say, okay, I want to have a multi-tenant system. I want to have a.example.com. I want to have b.example.com. I want to have c.example.com and have them all route to a single IP address. So what I'm going to do is I'm going to configure my server just to listen for anything. Don't. Configure Kestrel to listen to the host headers that are the ones that you know. So either you do it as, okay, well, I'm going to listen to star.example.com, which is fine because you've limited it now. Just don't listen for star. Don't accept anything. And, you know, always validate your inputs, which we did not do. And this one which is the last one, is not an MSRC case. It's not a Patch Tuesday issue. It's an advisory. And we take a great amount of pleasure in writing advisories, and then we realize no one ever reads them. This is an industry-wide thing. Again, it's about padding oracles. So this is not just us. This is Ruby. This is Java. This is Go. This is Node. When we wrote this, we then spent a year going around the industry demonstrating the problem, going, look, we need to at least update our documentation. We can't do anything about it because it's just a function of how everything works. But we need to update our documentation. And it's another oracle. It's another timing oracle. You see, we thought 5 years ago that encrypting and then adding a MAC was sufficient. The problem is that when you validate the MAC in languages that have exceptions, the way that MAC validation normally works is it will throw an exception that says this is invalid padding, rather than returning a yes or no. And exceptions take a bunch of time to actually build within the language because you have to get the call stack. And so you walk back up the call stack and you're pulling out all the parameters, and it takes an awful long time. You know, again, we're sub-milliseconds at this point, but as the internet gets faster, these things get detectable. As we all sit in shared hosting platforms, these things get even more detectable. You host in the cloud, an attacker can host in the cloud on a machine that's next to yours. So it's not just a matter of, oh, well, I'm going to sit in Las Vegas and attack something in Seattle and detect it over that way. It's like, well, no, I'm also going to host my attacking application in the same data center. So things will get routed around the data center. There's no direct access, but it's fast enough within the data center because these things have stupidly fast network cards. You can't fix this. It is a function of the language. It is a function of how exceptions work. So we don't expose padding oracles again. Again, we're falling back to this authenticated signature stuff. Now, if you can detect that an authenticated signature fail happens, that doesn't matter because you can't get around it. But again, we're back to this padding oracle stuff. So we are protecting and not throwing errors due to invalid padding. We are only throwing errors due to signature validation failure, which is fine. The padding stuff, not so much, because they can do this backwards working stuff. So in the advisory, which is, oh, it has a stunning URL, which is in the speaker notes for the slide deck, but it's on the docs site. It's 4338110 because we name things so wonderfully. It gives you how you can get around this in .NET. It gives you then links to other languages. I believe Java finally published an advisory, and I think that Google published an advisory for their bits and pieces. But it is just, when you are encrypting data, always sign it with an HMAC. And as for the rest of it, don't use regular expressions. They're just horrible. Honest to God, a regular expression that's that long, you can probably express better in code. Don't use binary formatter. Don't use serialization formatters that are not type limiting, where you can't say, oh, and by the way, I am expecting this type of object, and if it's anything else, I am going to reject it. Don't do overbinding in MVC. Always use the right HTTP verb, so don't use get when you should have used post. And validate your inputs. And that is basically it. I hope I've encouraged or scared, I honestly don't care, some of you to go look at your use of encryption and your use of serialization, because that's probably the most useful thing you can take away from this. And that is pretty much it. You know what? I'm going to be non-Swedish. Does anyone actually have any questions? Oh, you meet my expectations so well. I know some of this is a sensitive topic. People don't want to say, hey, is my code wrong in front of people. By all means, email me. My personal email is on my website. That's probably better to ask these things on, because, you know, if it goes to a Microsoft email, I'm sure people probably start feeling a little bit weird about emailing a corporate email account. So just email me offline, personal email, and I'll try to help as much as possible. Thank you very much.